Chidike never tell me waiting in the always they press for this place. Please off this fan. Alright, so welcome back to the second section. That's the part 2, okay, of Math 202 exercise, solution to Math 202 exercises. We are beginning with problem 4. Here we've covered 1 to 3 in part 1, and we are beginning with problem 4 in this part 2. Okay, so while we wait for some others to join, just be looking at this question. Just be looking at it. All right. Okay, so let's get to work. Okay. You're welcome. You're welcome. All right. Okay. Meanwhile, like I would always say, the time we use in probably waiting for people or trying to let every one of us try solving these problems themselves. I will take time to edit all of this. Okay, so by God's grace, let's see. Okay, so let's begin. This part 2, we are beginning with question 4, right? So, and question 4 says that we should integrate 2x plus 1 all over 4x squared plus 9 into the bracket of x squared plus 4. Okay, so and as usual, they started with some steps, and we are supposed to fill in some of the gaps in the process of solving. All right, So let's see how that goes. Okay, give me some minutes, I'll be back. Okay, so let's go on. Okay, so let's go on. Now so what do we do? Like they gave us, so first is you know that this is going to definitely be by partial fractions. So first of all, we will need to work on the function we are given. So we need to bring it out and then try to, you know, split it into its partial fractions. And the material we have already started the work, so we are just going to follow. All right, so you can see that the denominators are, they are distinct quadratic denominators. So we are going to have two fractions, sorry. So there will be two fractions. Let me use this, okay. So now the first will have a denominator of 4x squared plus 9. Then plus the second will have a denominator of x squared plus 4. So, and being that they are quadratic denominators, so the numerators will be linear. So you have ax plus b, and then the other one will be cx plus d. Okay, and of course this is what what we were given. Okay, let me try to reduce this just a bit so that we can have more space. All right, so what do we do from here now? So our intent now will be to find a way to begin to get our A, B, C, D. Okay, so first we will do that by taking LCM. Okay, so if we take the LCM, which is still 4x squared plus 9 into the bracket of x squared plus 4. Okay, so of course this will divide and cancel this, so we'll just have ax plus b multiplied by x squared plus 4, that's this other one. Okay, and then plus here you now have cx plus d multiplying this other one, because the denominator will cancel this, so we'll have 4x squared plus 9. All right, okay, so of course you know these two common denominators will cancel out, and when they do, we will just have the numerators will be equivalent. So we'll have that this is equal to ax plus b multiplied by x squared plus 4, then plus cx plus d multiplied by 4x squared plus 9. Okay, so of course, if you notice, this is the first thing that you are asked to put forward in your material. Okay, and they called it equation 1. Okay, so the next thing is to expand brackets, you know now to get our ABC we need to expand the bracket. Of course you can attempt using elimination, but you see elimination will not work because the x values we have here are squared, this and this, so no matter the x you put there, they will return for you positive values. Okay, so all right, so what do we do? Expansion will be the best. So ax times ax squared is as cubed. Then we will have, okay, plus ax times 4 ax times 4 so ax times 4 will give us 4ax, and then we come to b, you have bx squared and then plus 4b, and over to this side we will have cx times 4x squared will be 4cs cubed, and then that will give us plus 9cx, and then this times this will be 4dx squared, and then d times 9 will give us 9d. Okay, so that is going to be so we collect all the terms carrying s cubed. Okay, so we have a and 4c, so and that's going to give you s cubed multiplied by s cubed, and then we go for square, we have b there, square again, we have 4d, and that is multiplied by x squared. So we have picked this, we have picked this, this and this. Okay, so we go for x, and then for x we will have a 4a and 9c, that's this one and this one, 4a plus 9c, all by x, and then finally we gather those without x at all. That will include 4b plus 9d. I think those two alone. Okay, yes, and this we called equation 2. Okay, so what do we do next? We will try to now compare both sides of the equation. So recall that here is 2x plus 1, and so in comparing both sides of the equation, we are going to have that the coefficient of x3 will be equal to the coefficient of x3 on that side, and the same applies to x squared, x1, and so on. So what that means is, and that's where they said we should now set up the equations and solve. Okay, so let me give a little bit of some demarcations here that will help us. All right, so let's try to start our equations. So first you will see that a plus 4c is equal to 0. So because there is no s cube on the left, so its coefficient is 0. Now that's first. Second, b plus 4d is equal to 0 as well, and then this one, 4a plus 9c is equal to 2. Okay, and finally 4b plus 9d is equal to 1. That's the constant. Okay, so from our equations, we should then be able to start looking for some variables. Okay, let's try from here. Equation 1, we can make a the subject, and if we do that, or c, but I think a will be better because it won't involve a fraction. So we have a is equal to 4c. So substitute that into equation 3. Remember, I'm calling, you can ignore these equations I wrote here, sorry. So that's the 1 and 2 I wrote here. So these are the one I'm now calling 1, 2, 3, 4. So if you substitute this into equation 3, where you have you have A, that's going to give us 4 times A, which is minus 4C plus 9C will be equal to 2, okay? Alright, so that's going to give us minus 16C plus 9C. Let's do that at once. Minus 16 plus 9 will give us minus 7C is equal to 2. Therefore, our C alone is minus 2 over 7. Okay, so we have minus 2 over 7 for C. Alright, so now we can try to now get A, because A is a function of C. So we have minus 4 multiplied by minus 2 over 7, which is going to give us 8 over 7. Okay, so far we have gotten C and we have gotten A, right? So let's attempt to do for, we can close this. So let's attempt to do for the other one, B and D. Okay, and from say equation 2, you can see that B is equal to minus 4D as well. If we put it into equation 4 now, that's this last one. So we'll also get that 4 into B, which is minus 4D, plus 9D is equal to 1. Okay, in this case, you have that minus 7D will be equal to 1. So therefore, our D is equal to minus 1 over 7. Okay, and that's beautiful. So what will our B finally become? That will be minus 4 multiplied by minus 1 over 7, and that's equal to 4 all over 7. So we have the 4 values, D minus 1 over 7, B 4 over 7, A 8 over 7, and C minus 2 all over 7. Okay, so now we will now substitute all of that into the original equation we formed here. That's these partial fractions, okay, or fractions, sorry. All right, so yeah, of course it's fractions. Okay, so let me write that down here. So that means we are going to have A is 8 over 7. So we'll have, of course, if you turn over, you will see where we are now told, okay, what this is going to be. So that's 8 over 7x plus 4 over 7 all over this one now, which is 4x squared plus 9. Okay, and then for C and D, remember that C is minus 2 over 7. So we are going to have minus 2 over 7x, then minus what again? D is minus 1 over 7, minus 1 over 7, all over x squared plus 4. Now let's try to bring that down a little bit to use it. Okay, permit me to do this. Okay, so I'm going to take it down. Will you allow me to carry this? No, it has refused to go. Okay. Okay. So let me try to write it again down there. Okay, it looks like this board is already getting filled. Okay, so let's go over. Should we go over, or let me try? Okay, It's still going up. Okay, that means we can continue. Maybe after this question we go to another one. So that means that our 2x plus 1 all over 4x squared plus 9 into x squared plus 4 dx is now equal to, so let's bring down what we got there. That's 8 over 7x plus 4 over 7 all over 4x squared plus 9. Then we have plus, okay, so here we have, or let's do this at once. If you go up, okay, so if you come up here, you will see there is minus here and there's minus here. So I can factorize out minus, and that will change this plus to minus, and then this one will become plus plus. Okay, so let's go back. Okay, so all right, so here now we are going to have minus here, and then up here will now be 2. Okay, you can actually split it into two integrals. So this one should be dx, then minus, then that one will now be 2 over 7x, then plus 1 over 7 all over x squared plus 4, then dx as well. Okay, so these are the integrals that we have to deal with now. Okay, and in doing that, what do we do first? So you discover that, let me shift this. You discover that there is 1 over 7 across all the terms in the numerator. So I can actually bring out that 1 over 7, open a bigger bracket. So this one will now become integral of only 8x will remain here, only 4 will remain here, all over 4x squared plus 9 dx minus okay, then this one will be integral of, okay, only 2x will remain up, then only 1 will remain here, all over x squared plus 4 as well, then dx. Okay, so now notice that we can further do something else. And what is it? Try to split the fractions. So you are going to have 1 over 7 into the bracket of, okay, so if I split this, I'm going to have integral of 8x all over 4x squared plus 9 dx. That's for this one. Then plus this other one, which is integral of 4 all over 4x squared plus 9 dx as well. Okay, so then minus will now affect these two if I split them, and that will be minus 2x all over x squared plus 4 dx. Then another minus integral of 1 all over x squared plus 4 dx. Okay, so and this completes the 4 integrals that we expected to now simplify. Meanwhile, this part is part of where you would need to use to fill up the space they gave in the process of solving it. In the process of solving it in our material. Okay, excuse me. Okay, so going on, what do we do then? So we'll now start applying the rules of integration, the ones that we know. Okay, now what do we do here? There is a part of integration that told us that I think I mentioned it even in Maths 102, that if you have the integral of f prime of x all over f of x with respect to x, that this is the ln of f of x. Okay, so what's the meaning of this? That if I have a fraction, the integral of a fraction, and I discover that the numerator is simply the derivative of the denominator, that all I need to do is to state that that integral is equal to the ln of the denominator, that's natural log. And if you watch, you see that that happened here, that if you differentiate 4x squared plus 9, you will get 8x. Therefore, you are done. So the whole of that is the log, natural log of 4x squared plus 9. Okay, so we are done with the first one. Very simple. Okay, and what is the second going to be? Now there is a hint they gave us here which will guide us in getting the second. So just follow me for this second. You will need to pay attention. That hint says that if you have the integral of du all over u squared plus a, that this is the same thing as 1 over a multiplied by tan inverse of u over a, if I'm correct. Yes. Okay, now what does that mean? If I have a function that is squared added to a constant, this a here is a constant which is also squared, and the numerator as a denominator, and the numerator is simply the derivative of that function that is squared below, then that the integral of that arrangement is equal to 1 over that constant that was squared, then multiply by tan inverse of the function squared all over the constant squared. So if you watch what we have in the second part, you will see that it actually replicates the condition of this particular hint. Let's try to transform what we have there so that you see what I'm saying. We have integral of 4 all over 4x squared plus 9 with respect to x. You know I can write this as okay, I can actually write this as 4 all over, this one can be written as 2x all squared. Of course, this will give you 4x squared. Then plus 9 can be written as 3 squared. So if you watch carefully, remember your dx, you will see that your denominator is in this form now. So in that case, our u is 2x and our a is equal to 3. Okay, now we would need to make the numerator to be your du. So what's our du now? If you differentiate this u now, you are going to, that's with respect to x. Of course, with respect to x, you will have only 2. So, but I want that dx to cross over. So that will give me 2 dx. Okay, because I want du here. So 2 dx, of course, you see that there is 2 here. So I can actually write this as 2 integral of 2 dx. Let that dx come close. All over, maths is beautiful. All over, okay, this has gone too far. If I bring it down a little bit, let me be seeing the integrals. Okay, I think this is okay. It's okay. It's okay. All right. So all over. Now I have my okay. Let's okay. Let me still leave it as 2x all squared, then plus 3 squared. Okay. So immediately you can see now that this exactly replicates this. 2 dx is my du, and then 2x is my u, and then a is my 3. Okay, so immediately we can begin to write it in this form, and that's going to give us plus. So in writing it in this form, our a is 3, so you have 1 over 3 coming behind is going to multiply the 2 that is already, remember this 2 will multiply this whole integral, so that 1 over 3 will multiply this 2, so we are going to get 2 over 3 here, and then tan inverse, okay, permit me to now remove this, tan inverse of u over a, and our u is 2x, so let me remove that now, so that will be tan inverse of u, which is 2x, all over a, which is 3. This is so beautiful. So you see, that hint was very important to help us analyze this to get what the integral should be. So we come over here, which one works here? If you differentiate the denominator, you will definitely get the numerator, so the same pattern here will work here. So this will be minus the natural log of x squared plus 4. Okay, I should have loved to use another color here. Okay, so permit me to use green there. That's natural log of x squared plus 4, because the derivative of x squared is 2x, the derivative of 4 is 0, so you have 2x only. Okay, so we are done with that. We come over here. If you check, you see it looks like this also replicates the second one. Let's try to see if we can structure it. 1 all over x squared plus 4 dx. Okay, so in this case our u is equal to x, and our a is equal to 2. In fact, let me do that. Okay, so we can write this as 1, of course the dx can come up, that's 1 dx all over x squared, our u is x, and then 2 squared. Okay, so let me bring out that u, which is x. If you differentiate here, you get that your du is actually equal to the x. So up here is already your du, your u is x, and your a is 2. So we can quickly write it 1 all over 2 multiplied by tan inverse of x all over 2. Okay, so let's bring that up there. So let me use blue now. So we have minus 1 over 2 tan inverse of x all over 2. Oh, this is beautiful. So this is why I love maths. It allows you reason deep, and then you see some nice stuff in solving a problem. Okay, so what's this going to give us now? So we will now try to simplify what we have. Okay, do we really need to simplify? Okay, you can join this and this, although the space given in the material will just allow you to end here. So this is a good place to actually stop, but you can join this one and this one. Log minus log will give you log of 4x squared plus 9 all over x squared plus 4. So but because of space, so anyway we can write it, so we can push it to 1 over 7 in bracket of ln of 4x squared plus 9 all over x squared plus 4, because subtraction changes to division in logarithm, and then you can bring down the rest the way they are. So you have 2 over 3 tan inverse of 2x all over 3, then minus 1 over 3 tan inverse of x all over 2. This is so beautiful. So it's a good place to end or to stop in that solution. All right, so and that is the solution for problem 4. I don't know what you got when I asked us to look at it. Okay, so let's go to page, another new page please, because of space. Okay, so here we will have problem 5 now. All right, and problem 5, we are told to evaluate the integral of, so if you notice, you see that most of the things we are doing now are just integrals, because that is a review of the prerequisite. Most of the things you do when it comes to solving differential equations is integration. So you need to be grounded in the steps of integration. So, and that's why this review is coming. All right, so let's look at what we have. Okay, so what do we do here? They started also with some hints or steps and expect us to, to fill up. So what was the first thing they said? We should use substitution. So let our u be equal to the square root. This time around we are not making u what is under the square root, so we are picking the whole of the square root, and from here if the square root crosses over, you get u squared is equal to x plus 4. And then that is not all. From there you can make x the subject and you get u squared minus 4. So with this we can replace or rewrite this integral that all of it will be in terms of u and there will be no radical. I think that's beautiful. So if you replace here, you will get that the numerator is u, and what's the denominator? The denominator is u squared minus 4, but you now have the x here, so you need to replace that. And to get your dx, all you need to do is there are two things you can do: either differentiate this with respect to u, or you can yeah, I think that's better, or you can differentiate this one. So but I think I prefer this, right? So if we differentiate this with, that's differentiating x with respect to u, we will get 2u. This will turn to 0, so that means our dx is 2u times du. That's if this one crosses over. So we just have multiplied by 2u then du. So everything we have now is in terms of u. So I think I should move this guy to the end of that line. Yeah, so let it be here, so that everything is together. Okay, of course this one also gave rise to this, so this produced this produced this, and this also produced this. Okay, so now we will now have to evaluate what we have here. So if we bring it down here, you will see that you are going to, or permit me to reduce a little bit. Okay, I think this is nice. Okay, then I'd have to remove this. Okay, so now you see that what we now have, of course, u times 2u will give us 2u squared all over u squared minus 4 then du. Okay, so and our job now is to integrate this, and of course you can see this can also lead us to partial fractions, but you need to reduce this because the degree of your numerator is the same as the degree of the denominator, so you need to reduce it. However, they already gave us a reduction which I would not like that we will go to repeat. So this is the same thing as 2. Of course I'm bringing out this 2, and so they said is equal to 1 plus 4 all over u squared minus 4. Okay, then du. So what did they do there? Is just simple division of polynomials. In fact, let me try to do that. So you divided u squared by u minus 4. Remember, we factorized out 2, so it's not part of that. Okay, so let's try to run that division. U squared divide u squared is 1. 1 times this will give you u squared minus 4. If you subtract, this will go. So then, of course, there is 0 here. So 0 minus minus 4 will give you plus 4. And u squared cannot divide 4. And so that becomes a remainder here, which is 4 all over this. That's actually how this was gotten. Okay, so from here we are now told to now further split this one into its partial fractions, and that is easy to do. So let's do it somewhere and then bring it up. Okay, so of course you know that 4 all over u squared minus 4 is the same thing as 4 all over u minus 2 into u plus 2 because of difference of two squares. Okay, so which is going to give us a all over u minus 2 plus b all over u plus 2. By the time you take LCM, you get that 4 is equal to a into u plus 2 plus b into u minus 2. Beautiful. So to get our a now, we can substitute b as 2, u as 2 to eliminate this. And if we do that, we will get 4 is equal to 4a turn off that alarm. I go stop to dey come here. Run the talk and small. Okay, so sorry about that distraction. So here we are going to have that our a is equal to 1, and to get our b we need to eliminate a, and to eliminate a we will call our u minus 2. So of course that will give us 4 equal to minus 2 here will go, then minus 2 here will be minus 4b, so which means our b is equal to minus 1. Okay, so if we now bring all of that here, that's going to give us 2 into the integral of 1 plus here you will now have 1 over u minus 2, then here you have minus 1 over u plus 2. Okay, right? So, and then of course you have our dx here. So permit me to remove all of these. They are not necessary that you write them, so you can just do it like a rough and then bring here. Okay, so here now we are going to now evaluate that. So we have 2 into the bracket of, if you integrate 1 with respect to u, remember that this thing is du not dx, sorry. So if we integrate 1 with respect to u, we will get u, then plus if we integrate this with respect to u, of course the derivative of u minus 2 is 1, so it satisfies that condition of f prime of x all over f of x being equal to the lane of f of x. Okay, so that's what we are going to do here. So this is going to give us the natural log of u minus 2. Okay, and then this one also satisfies that condition. The derivative of this is also 1, so we also have the natural log of u plus 2. Okay, and that is all for that. Of course you put your plus c. So now remember, like I said earlier in previous example, you can stop here, or you can as well decide to, okay, meanwhile we've not brought back our u. Okay, so let's do that. So you bring back our u. Recall that our u is square root of x plus 4. So we'll have square root of x plus 4, then plus the natural log of square root of x plus 4 minus 2, then minus the natural log of square root of x plus 4, then plus 2. Okay, so this is what we have. Okay, and like I said in that earlier example, that's problem 4, you can actually decide to write this in other ways. If I open the bracket, okay, first of all, this can be written as the square root of x squared plus 4, Then if you join the logarithm, you know that subtraction will change to division. So we'll have the square root of x squared plus 4 minus 2 all over the square root of x squared plus 4 then plus 2. Beautiful. Okay, so and if you open the bracket finally, you will now get that, of course, this will multiply this to give you 2 root x squared plus 4. Then plus 2 will also multiply that to give us 2 log of square root of x squared and you are done. You are done. Of course, remember our constant c. Our constant c should be there, even here. Okay, so all right. Okay, so and that is the solution to that particular question, and that is problem 6. Okay, so I will try to, okay, that's problem 5 rather. So I'll try to see if we are able to look at problem 6, okay, before, because I wouldn't want all of these live sections to be exceeding an hour. So maybe after this I will end this and probably start another one, so that for those that will watch it later, they wouldn't have to watch for so long. Okay, so problem 6 is also another integration. So it's asking us to integrate from 0 to pi over 2 of what? Of sine squared x multiplied by cos squared x and then dx. Okay, so this is what we are asked to do. I will permit or allow you to look over it for some minutes. I'll be back. Okay, so I'm back. So what do we do here? We will try to see what we can do. Now first is that there is a hint we have, so always pay attention to the hint. So let me first of all write it out. It says that we should recall that sine squared x is equal to 1 over 2 of 1 minus cos squared x. You will get this from compound angles in trigonometry, and then the same will happen here. Cos squared x is equal to 1 over 2 of 1. This time is plus cos 2x. Okay, so if you expand cos 2x, which is cos x plus x, you will get sine squared inside. If you expand this, you also get, and all of that. Okay. Okay. Is it supposed to be cos 2x or sine 2x? Okay. Okay, let's see. Okay, so that's what the hint says. So let's try to apply it. Now, why is it necessary that we will bring in this? Because when it comes to power, integration of powers of trig functions can be very tedious. So it's always good to bring them in a form that does not have power. Okay, so that means this is going to become integral of 0. Of course, this is definite integral. So from 0 to pi over 2. So we are going to have sine squared x is is half outside here, times 1 minus cos 2x, then multiplied by half again into the bracket of 1 plus cos 2x. Okay, we close the bracket and then we have the x. Okay, so let's shift a little bit here now. So what do we get from that? You are going to have, of course, half times half is 1 over 4. So we can bring those constants outside. So we have 1 over 4 integral of, so you can now multiply this bracket by this bracket. And if you notice, you see that that's difference of two squares, a plus b into a minus b equal to a squared minus b squared. So that's what I'm going to do now. My a is 1, so the square of 1 is 1, minus my b is cos square of 2x. So I will square that now. Okay, so and that's what we've got. Okay, then you have your dx. Okay, so you see that what I just did now was given by a blank space which you are expected to fill up. Okay, so what do we do next? So we'll now try to as well bring in this one in the form of this. Okay, so and to do that we are going to have 1 over 4 integral of already we have 1, then minus, so this is going to be half again, then of course remember that half is multiplying 1 minus cos of 2, is cosine is plus cos of 4x, because 2 will now multiply the already existing 2x, so that would be 4x and then plus 1. Okay, all right, so and close every bracket. This is the x. Okay, so what do we have now? We can open the bracket if we want and split this into two integrals. So this will be 1 over 4 integral 1 dx minus this one multiplying this will now become 1 over 8. So we have 1 over 8 integral of 1 plus cos 4x, okay, and then dx. All right, so at that point we can now do the integration. So if you integrate x with respect to x, you get x, so x over 4. So if you integrate 1 with respect to x, you get x over 4, or you can actually write it this way, 1 over 4, then attach your x. You know that these two are actually the same, that's this and the one I removed. And so we now have minus, okay, so when you subtract now, so this is going to be, remember you have 1 over 8 outside, and then when you integrate 1 again, you will get x, and if you integrate cos, integration of cos will give you sine 4x all over, remember is a function of function, so after integrating you now differentiate this and use it to divide, so this will give us all over 4, and that is plus a constant what? C. But remember that this is definite integral, so you are moving and since it's definite integral, you may not necessarily put the constant, so but recall that you are moving from 0 to pi over 2. I omitted that all along, okay, so remember to put that, okay, remember to put that in other areas. Okay, so let's now try to finalize that evaluation. So we bring down this one, it's already done, so and this one again. Okay, let's just keep our 1 over 8 and then open the bracket, put pi over 2, so this will give us pi over 2 plus, here if you put pi over 2, 4 as your x, of course, 4 will now multiply pi over 2, and this will cancel this to give us 2 pi. So we are going to have the sine of 2 pi all over 4, and then the whole of this will be subtracted. We'll subtract this one, that's substituting this. Let's put it this way, bracket here. So if we substitute here, we have 0, and plus if we substitute here, we have sine 0 over 4. Of course, sine 0 is 0, so all of this will go away. So confirm that sine 0 is equal to 0. Okay, so everything here will actually disappear, so I think it's sufficient to stop here. So of course you want to write it, you can, because what did I do? Okay, so because no difference. So all right, so from here now we can now open the final bracket. So we have 1 over 4x, this multiplying this will be minus pi over 16, then this multiplying this will be minus, so this will be minus sine 2 pi. Remember that sine 2 pi is in radians, but 2 pi is 360 in degrees, so we can check sine 360 degrees. So which is also 0. Wow, that's beautiful. So the whole of this will as well go. So that means we are done, that this is our solution. Okay, so by the time you substitute, that this is what you would get. Okay, meanwhile, remember that we integrated this one without substituting. Oh my god, so we didn't substitute the definite integral, and that's why we've been carrying all this x all along. So let's try to substitute there. So here we are supposed to have from 0 to pi over 2. So in other words, this is now supposed to be equal to, if you watch here, if you substitute pi over 2, the 2 will come down, so we are going to have pi over 8 actually, right? And then of course when you put 0 times 1 over 4 is 0, so that one will go. So we just have only pi over 8 here. So by the time you subtract this, you are going to have LCM is 16, so that's going to give us 16. 8 into this is 2 times pi is 2 pi minus pi. So our answer is pi all over 16. Oh, that's beautiful. So the solution is pi over 16. Okay, and that is for the integral or the question or problem number 6. Okay, and I think we are beyond an hour already, so I am going to stop here or pause here for a moment, and then when we return we will continue from problem 7. Okay, so let's take that break. Now please do give thumbs up to this. Whenever you see this video, make your comment and then tell us what you would like us to do or what we are not doing well, and if you have any question you can ask. We'll see you in the next one. Bye. Okay, so the two